Good morning. It has been an early start for the team at Launch Complex 1 in New Zealand, where Electron is on the pad and ready to launch its next mission to space. And we'll be carrying a single satellite to a sun-synchronous low Earth orbit today when Electron lifts off the pad in about 16 minutes' time for its 73rd launch. And it's great to have you join us. My name is Muriel Baker.
And I'm Lakita Satrasala. Together with Muriel, we'll be taking you through today's countdown to liftoff for Electron's next mission for Japan's satellite data and analytics company Synspective. Today's launch is called Our New World, a continuation of our owl-themed mission names that reference Synspective's StriX series satellites.
The mission names all relate to owls because StriX, the name for their satellites, is also a genus of owls that belong to a certain owl family, sometimes commonly called wood owls. And we've launched 6 owls or satellites on Electron before, but the one on today's launch is a next-generation StriX that Synspective will use for its synthetic aperture radar imaging constellation. It's also the first of 21 upcoming missions to build out that constellation before the end of the decade, the largest multi-launch agreement we have in place for a single customer for Electron. Now, each launch is specific to Synspective's mission, and today's rocket fairing is a great example of that. If you have a look at the top of the launch vehicle there, you might have noticed a bit of an unusual shape to it, and that is because we have deployed a customized fairing for this mission to accommodate the wide body of that StriX satellite. Those blades that you can see on the fairing are for the full edge of the satellite on all sides.
It's just one of many variations we can make to our composite split clamshell design for customers with payload that exceed the standard fairing size. We can do dual stack payloads, longer fairings for taller satellites, expanded fairings for wider-bodied spacecraft, just like this one, and you name it. For today's mission, we brought out the Arrowhead fairing, which is our internal name for this extremely unique fairing shape within the industry. This fairing comes with its own engineering challenges due to its aerodynamic profile, but we do the impossible here at Rocket Lab. As a structure analyst on this project, I can testify to many engineering hours put into this mission to get us onto the pad today. We're looking forward to seeing many more owls on Electron fairing in the years to come. Here's more about Synspective's mission.
We are developing and operating the synthetic aperture radar satellite to understand our Earth scientifically, quantitatively, and rethink about the economic activity, climate change, or disaster mitigation. Then we provide the insight and needed information to the governmental users and the private sector's users.
The SAR satellite can operate without light at any time of the day, even at night, or even when there's rain, to detect objects on the ground. We are able to play a role very much in weather adverse scenarios, for example, in flooding, in typhoons.
We work on using the disaster damage assessment solution to quickly output some disaster area estimation to send to local agencies so they can use it for the local relief.
And also we can expand the collaboration with other sensors, maybe comes from our partner companies, to accelerate the resilient world. So I think a very hopeful approach.
It's great to be back on the pad again for Synspective. Today's launch will deploy the 7 StriX to orbit on what we call a dedicated mission, which means Synspective has control over when they launch and where they launch to really tailor their constellation exactly how they want to.
And right now, that 7th StriX and Synspective are just 12 or so minutes away from heading to space again. So let's check in with the launch operators in mission control to confirm that everything remains on track and listen into the go, no-go poll for today's liftoff.
Toss station dialed in mission core proceeding with the go no go sequence. Stage?
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC's go.
Beacon,
Beacon is go.
T1,
T1 is go.
GC,
GC is go.
PLS,
PLS is go.
RSO,
RSO is go.
MET,
Med is go.
MM,
MM is go.
LDSUP.
LDSUP is go.
Go, no go sequence complete. We are T minus 11 minutes, 21 seconds and counting. We are go for terminal count auto sequence at T minus 10 minutes. From this time, the 3-word procedure is in effect.
Great news from Mission Control. That clear run through the poll means that we are go for today's launch attempt of Electron's 73rd mission. Liftoff is currently set for 5:33 a.m. local time or 16:33 UTC. And if you're watching from Japan, the timing is 1:33 a.m. For our East Coast viewers, that launch time is 12:33 p.m. And for those on Pacific time, the T0 is 9:33 a.m.
As you can probably recognize from our views of the pad, we're launching today from Rocket Lab Launch Complex 1 on the Mahia Peninsula in New Zealand, our primary launch site for Electron missions. But it's the first time we've launched from here for a while, actually, after a couple of busy weeks over at our Eastern Shore launch site on Wallops Island, Virginia, where we have a launch pad for Electron and HASTE missions out of Rocket Lab Launch Complex 2 within the Mid-Atlantic Regional Spaceport.
And of course, right next door is our brand new launch site for our much bigger rocket Neutron. And no surprises with what we've named this one after Launch Complex 1. And 2, of course, comes Launch Complex 3, which is our dedicated test, launch and landing site for our upcoming medium lift reusable rocket. We cut the ribbon on Launch Complex 3 just over 6 weeks ago, actually, after building it from the ground up in under 2 years. An incredible achievement made possible with some great partnerships and solid teamwork. Now, here's more about Launch Complex 3.
And Launch Complex 3, looks a little different than most other orbital launch pads of a vehicle this class. And we did that intentionally to reduce the amount of bespoke infrastructure that needs to be created to support this rocket. You'll see the pad is quite clean with its propellant farms supporting the main launch pad in itself. And that's really largely there to minimize the amount of infrastructure needed for rapid reuse.
Launch Complex 3 is a world-class medium-lift launch facility. It's constructed on pile-supported foundations. There's over 650 concrete reinforced piles that are between 70 and 80 feet in length. We have over 5,000 cubic yards of concrete on site for the foundations. In addition to that, we have approximately 700 tons of steel in the launch mount itself. We have a water tower that has a 200,000-gallon capacity and even more capacity in our cryogenic propellant storage on site. If you go out radially from the launch mount, you'll see a series of buildings that we call the launch equipment vaults. Those house all the electrical and controls equipment needed for both the ground systems and the launch vehicle itself. Towards the perimeter of the site, you'll notice large tanks. Those are the propellant farms that store and ultimately load Neutron with the fuel and oxidizer ahead of test and launch campaigns. There's quite a few block upgrades that are planned for Launch Complex 3. Most notably, you'll see block upgrades to the lifting and integration infrastructure out on the launch site itself. In addition to that, you'll see a doubling of propellant storage and a number of other assets put in place to support rapid turnaround times for both test opportunities as well as missions.
With Launch Complex 3 being the 4th launch pad we've built as a company, we've got a lot of experience in bringing infrastructure to life very, very quickly. We're also familiar with the Wallops Island and the NASA and the Virginia space teams, so that's enabled us to really hit the ground running in getting this pad built in record time.
Neutron is revolutionary in its design, revolutionary in its construction, and its operating model. This will bring a new capability and expanding the lift capability at the Mid-Atlantic Regional Spaceport. We have a marvelous relationship with Rocket Lab, and we're excited about beginning to launch the new Neutron rocket. Exciting times ahead as space continues to grow.
Rocket Lab with Neutron at Wallops represents an expansion of the launch capacity that's needed in the United States. You can't launch everything from the Cape, and the United States needs both Wallops and the Cape to be able to enable us to go to the moon and onto Mars.
The Rocket Lab team at LC3 is one of the best teams that I've ever worked with. It's a pretty driven group of individuals, and I'm super excited to see construction come to a completion and move into the test campaigns with the flight hardware.
You know, Sir Peter said at the opening that he thinks the site looks so good it could be an architectural monument, and I'd agree with that. What do you think, Lakita?
Yeah, most definitely. It looks really good, and some of the stats behind the build are just incredible. More than 5,000 cubic yards of concrete foundations, over 700 tons of steel in the launch mount, a water tower with a 200,000 plus gallon capacity, and nearly 200,000 gallons each for the propellant storage tanks. Just a super impressive amount of infrastructure and construction that's gone into LC3, given how sleek it looks from the outside.
Absolutely. A really excellent job by the local Wallops Island team and contractors that made it happen. And with Launch Complex 3 now officially open, that does mean soon we'll be starting to see Neutron flight hardware make its way to the site for complete integrated systems testing and launch operations in the lead up to its maiden flight. Super exciting to see it all coming together now.
Also, how cool would it be if we were launching to Mars from Mars? When Neutron launches from Virginia, it will bring the largest lift capacity to the eastern shore in the spaceport's history. And what better way to utilize that capability than to help build crucial infrastructure for Mars exploration? That's the vision we have for our Mars Telecommunication Orbiter, a spacecraft to provide communications for future crewed and robotic missions at Mars, and maybe even support efforts to return the Mars samples that are waiting to come home. We're ready to do it. Here's a video to show you how. Talk first, land later. Really sums it up, doesn't it? What an exciting mission.
Yeah, straight to the point. Okay, here we go. We are now 3 minutes, 41 seconds and counting from launching the Our New World mission for Synspective on Electron from right here on Pad A at Launch Complex 1. Let's take you through what is about to happen next. So at T-minus 2 minutes, we enter into what is known as the final count. And by this point, Electron is topped up with its fuel and oxidizer propellants, with the liquid oxygen set at a super cold cryogenic temperature that will cause moisture on the outside of the rocket to freeze. And that's where you can see those white stripes against Electron's black carbon composite structure.
The operators in mission control are making their way through their final checks so that all launch systems are green and remain green right at the T0 mark. By this point as well, Electron's flight computer will have taken over the countdown to run through the final automated sequences before launch. Electron's first and second stages will be fully pressurized and ready for launch. And then it's down to launch director's final count, along with the mission clock from T-minus 10 seconds till liftoff.
We are just moments away from those final actions now, so we're going to bring up the audio channels from Mission Control to listen in, and then Lakita and I will be back with you after liftoff. So go Electron, go Synspective, and go StriX.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over.
Stage 1 propulsion is nominal.
There goes Electron, launching into an all-new world with our 7th mission for Synspective. We've cleared the pad and Electron is now about 42 seconds into flight and climbing nominally in both speed and altitude, which means next up for this phase of flight will be max Q, or maximum aerodynamic pressure. The guidance, navigation and control team will give us a call once we've cleared that point in the launch, so let's listen in.
Cleared max Q.
There we go. Electron has successfully cleared max Q, and the first stage's 9 Rutherford engines are burning hot to take us past 16 kilometers in altitude now at over 2,000 kilometers an hour. Now, those engines have another 60 seconds or so to go before we reach the next point in flight, which is main engine cutoff, or MECO, on the first stage. And this is when all 9 of those engines shut down at the same time, just ahead of Electron's second stage separation event. That shutdown helps to ease Electron's velocity just a touch for stage separation before the second stage's own Rutherford engine ignites for its engine burn to deliver the mission closer to orbit.
This all happens very quickly, within just a few seconds, so keep an eye across the views in front of you to watch it all from Electron's onboard cameras. And let's listen in for those calls from Mission Control.
Enter it burnout detect mode.
10 seconds till staging.
MECO confirmed.
Separation confirmed.
Stage 2 ignition confirmed.
A beautiful sequence of events there. That was a successful MECO, stage separation, and second stage ignition, all within a matter of seconds for Electron.
And up next, we should see Electron's arrowhead fairing separate and fall away, so let's watch and listen for that now.
Fairing jettison confirmed.
Nice one. There goes Electron's fairing, and there was the StriX satellite live on your screen
Stage
being
2
propelled
propulsion is
closer
nominal.
and closer to orbit to join the 6 other StriX satellites already there thanks to Electron. Now, under 6 minutes of engine runtime for this second stage Rutherford to go. The mission otherwise is now past 129, just ticked 130 kilometers up in altitude and moving along at over 8,000 kilometers an hour.
HVB discharge holding nominal.
The version of Rutherford engine used for the second stage is practically the same as the sea level version used for the first stage, just with a few more pounds of thrust per engine and a higher specific impulse of 343 seconds compared to 311 seconds for the sea level version. This basically means that the engine with the higher value of specific impulse is more efficient, because it produces more thrust for the same amount of propellant. Across both types of engines, though, we use batteries to electrically pump the Rutherford's fuel. And for the second stage engine, we need to swap those batteries out as the engine's runtime drains them.
This is called the battery hot swap, and it's a maneuver that you'll only find on Electron and for these engines. And we're coming up on that milestone very shortly, with battery hot swap scheduled to take place at around 6 minutes and 36 seconds into flight, not too far away now. And you might actually see the spent batteries from the stage 2 disconnect and fall away when that happens. So look out for a shiny silver object being jettisoned to know that the battery hot swap has taken place.
Guidance is nominal, 200 seconds remaining.
HVB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
Good
Confirm
confirmation
hot swap
there from the
successful.
team in Mission Control. A fresh set of batteries are now in place and battery hot swap was successful. We've got about 2 minutes left of engine burn time for the second stage before we come up on the next set of events for Electron. Those will be SECO, or second engine cutoff, when the engine shuts down in preparation for kick stage separation, repeating the actions we saw earlier between Electron's first stage and second stage. We are expecting SECO to take place in around 9 minutes 13 seconds into flight, so not long to go now. Alright, we're coming up to second engine cutoff on Electron's second stage very soon. Now, much like the earlier separation event that took place during the first phase of launch, we should see the engine shut down in preparation for separation with the kick stage, which is currently carrying Synspective satellite.
Now, once the engine shuts off and the kick stage separates for its phase of the journey, its own little Curie engine won't light up right away. Instead, it will go into a bit of a coast phase around the Earth to help line up its trajectory for the orbital target that we've been set for this mission. And that cruise takes around 46 minutes or so until it's time for the kick stage's Curie engine to ignite. First, let's make our way through SECO, which, looking at the clock now, should be coming up in just a few short moments.
Nominal transfer orbit achieved.
Stage separation confirmed.
Beautiful shutdown and separation there for Electron's second stage, and welcome to the final leg of the journey for Synspective, now that the kick stage is off and on its way around Earth with that 7th StriX satellite. Now, as we said before, we go into a bit of a coast phase here to allow the kick stage to circle back around and reconnect the dots at the mission's target apogee. Once it's there, the Curie engine on the kick stage will light up to course correct that trajectory, and then we'll be only a minute or two away from payload deployment and the end of the launch.
We'll join you back here to see through those final moments of the journey. Hang tight for now, and we'll be back again in about 40 minutes or so to add to the Parliament of Owls. We'll see you soon. Hello and welcome back to our latest launch for Synspective. We've entered an all-new world with this mission, with our Electron rocket carrying the 7th StriX satellite to space to join the rest of its constellation already deployed there by Rocket Lab. We had a successful 73rd liftoff today at 5:33 a.m. local time from Rocket Lab Launch Complex 1 in New Zealand, and a clean run through the usual launch milestones to bring us to this point in the launch.
While we were off air, the Curie engine completed a successful ignition to set the stage for payload deployment for the 7th StriX. So we are now just moments away from payload deployment. And we've got an animation of that sequence to track what happens in real time. So we're going to bring that up now to watch along while we listen in to Mission Control to hear the final call-outs of the mission.
Payloads separation StriX 5 confirmed.
Nominal.
A beautiful payload deployment for the 7th StriX satellite. Welcome to orbit again, Synspective. That's mission success for Electron's 73rd mission and 15th launch this year. And don't worry, we've got plenty more ELs to fly for Synspective, with today's mission being the first of 21 upcoming launches to deliver Synspective's constellation to space before the end of the decade.
It's a fantastic partnership that we are proud to be part of, and congratulations again to Synspective on another StriX successfully delivered to space. All the very best with the satellite commissioning to come. For now though, that is a wrap on today's launch coverage. Thank you for joining us as always, and until next time, this is Rocket Lab Mission Control signing off.